Hello, my name is Ernest Braimoh. I recently finished a project uh, with the logistics and delivery company. They had a questionnaire with questions. They got feedback from their customers. They want to find out the insights that drives them being happy or unhappy. And they want a data machine learning model that will show them the insights or the features that make the customers happy or unhappy. This is the project. They are all in my GitHub file. You can check out my GitHub file. I will leave the links with you. I imported the packages necessary and the data sets. So we have the target variable, which is 0 for unhappy, 1 for the customer. And these are the questions on the questionnaire. Checking to see the validity of the data sets. And so far, there's no more. These some EDAs to get some insights from the input variables. Uh, Check to see if the target variable is balanced, if the difference is not so much, and I try to go ahead because the difference is not too much. So the correlation showed that the other's importance is X1 is most important to X2 by correlation. So in this project, I'm focusing on what makes the customer unhappy because the happy customers, from my insight, they're already with the firm, they're enjoying the services. But the unhappy ones, they will love to win them over so that to prevent churn. I did some PCA. The PCA showed that X1 is contributed 7%, X2 is contributing 90% to them be happy or unhappy. But I'm going to take this step further. But first of all, trying to boost the other boost and the gradient boost, they gave me 60% and 63%, as you can see here. Let it predict what used because it has so many models that it can use to work on the data set. I ran it through the data set and I collected this as the best model so far to be used from perceptron to SGB classifier. Right there, I ran them through the data set again, this time using the seed. As you can see, my random seed, making sure that the target variable remains the same in terms of it's being splitted so that you will the answers will be getting the accuracy and all will be getting will be valid. Then if we have 100%, if it comes out 100% accuracy, I'm rejecting it because it tends to overfitting. So after 50 iterations, nearest central got 20 of the highest accuracy in terms of the recall. Remember, I'm using recall equal to 0. What makes the customers unhappy? That is what I'm working on. Then I also check the highest recall of that came out from the 50 iteration that was run, and I got 3 other of the SG, the classifier, the other boost classifier, and the perceptron. So what I did was to use the nearest centroid with the seed, and I got 92% accuracy because it was consistent 20 times of the 50 iterations I did. And the accuracy is 77%, which is not too bad. So this is the confirm matrix to uh, visualize the answer, the results we got. So the next thing I did was to take the nearest centroid and two other classifiers for their best random states, the SG, the C classifier, and the perceptron. I use them for the ensemble. So this is the voting classifier model. So what voting classifier will do is to select the best answers from three models and display it. I also use the staking, which will come to us very soon. So the best answer I got from running the iteration again with different seeds again was that the seed is 7833. I gave the best answer with the ensemble, which is 83% in recall and 81% in accuracy. So this is the confirmation to show the answer. So this is the staking. What staking does is they use the algorithm of the three classifiers together and optimize them and make sure they get the best answer you want out of the model being used. But again, 50 iteration with different random seed. I got 8269 as the best seed, and the recall was 92% for the unhappy customers. As you can see there, why the accuracy was 2%. This is the confusion matrix to show that also. So the next thing I did was I used the ROFE picture selection. Let's see feature evaluation. So the RFE, the recursive feature elimination, it showed me that X1, the same thing that we got from the correlation, if you remember, is still the best in terms of getting the weak call, the zero, the unhappy customers, and X2 is the weakest. So my model that I selected, the nearest centroid, I used it to start eliminating the features one after the other, starting from this weakest, the X2, then I'll get to the X1. This is the Python code. Okay, so this was the first result I got. It's such the centroid on everything there on the whole data set. And I started eliminating one after the other. Please, I don't want the video so long, so I'm going to the last one because that's where the result really came out. So when it was made those two features, the recall jumped to some 2%, accuracy 69. But when I used X1 only, I got 73% accuracy and recall 83%. It shows that the X1 feature is the most important in getting the unhappy customers. All right. Getting the insight to their unhappy customers uh, questionnaires that was answered. So then I tried the app out, which was developed by James Dextra. So it's different for lazy predictive because this time around we're using the hyperparameters within the models, and person trial gave me for 2.3% accuracy. Extra tree classifier was the model. These are the parameters within them. But at the end of the day, hyperops didn't get a better result, but nearest central remains the best model to classify unhappy customers. So it took about 5 minutes to run the whole Python code, as you can see here. So this is the background. This was aside from this, the things I did, the result that came out from it. So I said the key insight is I said the key insight is that the X1, as you can see, my order was delivered on time. The X1 achieved a recall of 83%. So what this means is what made the customer unhappy is that their orders were not delivered on time. If the orders are not delivered on time, they will be unhappy. This is one of the greatest, this is the greatest actually feature that needs to be looked into, greater in terms of paying attention to it. So the firm, the company, logistic company, will make sure that their delivery will come in on time. If it comes in on time, then the unhappy ones, most of them will move to the side of being happy with the firm, and churn will be presented. Okay, so this is the work I did. What are the expected impacts? The expected impact are listed here. So proactively identify unhappy customers and address their concerns. So to show that X1 is on top of that list, optimize delivery operations based on data-driven insight. So whatever they can do to make sure they get their delivery on time should be looked into. Improve our customer experience, leading to increase retention and brand loyalty. So churn will be prevented. So the questionnaires can also be streamlined since we have the weak question in terms of feature selection and correlation that was not really given the insight into unhappy customers. But that's what I want the firm to look into, not just focus on the happy ones, but focus more on the unhappy ones. But like I said, the happy ones are already enjoying the services. The retention will be there. It will be high. But for the unhappy ones, most probably they will leave the service and sort some other services to carry out their businesses. So this machine learning project provides structured approach to predicting satisfaction, allowing the companies to take corrective measures and enhance customer satisfaction scale. So that is what I have for us for today. Thank you very much for staying with me. I appreciate you. Thank you.